The first planets orbiting distant stars were discovered just recently in the 1990s. We call them exoplanets. Now, researchers have found over 5,000 confirmed exoplanets. But a relatively small number of these worlds are similar to Earth. Here are the top 3 worlds that remind us the most of home. Kepler 186f. In 2014, NASA's Kepler Space Telescope discovered the first Earth-sized world in the habitable zone of another star. It's in orbit around a star called Kepler 186, about 500 light-years from Earth. Astrophysicist Dr. Moiya McTier completed her doctoral thesis in exoplanet habitability.
Planets with orbits that are too eccentric or too far from circular experience these large temperature swings as they get closer to and farther away from their host star. But I found in my research that Kepler 186f actually has a pretty low eccentricity, meaning its orbit is fairly circular and it doesn't have those large temperature swings, and that makes it more likely to be habitable.
Next up, Kepler 452b. NASA considers this exoplanet and its star to be the closest analog to our planet and Sun so far. Though it is 60% larger than Earth in diameter, Kepler 452b is thought to be rocky and within the habitable zone of a G-type star similar to ours. The habitable zone is sometimes called the Goldilocks zone, meaning it's the right distance from the star to be not too hot and not too cold for liquid water to exist on the surface, meaning life could potentially exist there too. And finally, located about 40 light-years away, the TRAPPIST-1 system has quickly and rightfully garnered a lot of interest. Not only do all 7 planets in the system appear to be Earth-sized and rocky, 3 of them are located in the habitable zone of their star. However, these planets are not Earth's long-lost twins. Some research based on computer modeling suggests these planets may have developed like Venus, making them too hot to host water. In fact, TRAPPIST-1e may be the only planet in the system still welcoming to life, but without more data, it's impossible to confirm.
I like to think of the waves of exoplanet research as different eras. So when we found the first exoplanet in the 1990s, I'd say that was the start of the era of exoplanet discovery. We just wanted to find as many exoplanets as we could. But now we've found more than 5,000 of them. So for the last decade, I'd say we've been in the era of exoplanet characterization, where we were trying to learn as much about these individual planets as we could. Does that planet have water? Does that planet have a rocky surface? But as we find more and more exoplanets and we get these large populations of different types of planets, we are ushering in the era of exoplanet population statistics. We can study ensembles of planets to figure out what types are more common, what types are more special, and really we're trying to figure out, is Earth special as a planet?
There's something deeply humbling in looking to far-flung worlds for something shared with our own. It takes a lot of precise circumstances for a planet like ours to exist. The idea that these exact conditions could repeat themselves doesn't detract from how special Earth is. However, it does amplify the possibility that life can thrive somewhere else.